All right, this is our process control project. It's called the Cuddle Buddy Volume Controller. It's controlling the volume on both of the TV and a laptop to be able to maintain a set loudness by adjusting the volume. This was worked on by Tanner, Jens, Colton, and myself.
And so the problem that we are having is when watching a movie, you don't really want to hold the remote in your hand to regulate the loudness. And so we developed a device that can sense the loudness and adjust the volume of the TV setting or on a laptop. And the control is smooth and it does not disrupt the audio.
So the theory behind this, or the trick to figuring this out was we needed to define loudness. So we used the equation shown here to define our sensed loudness, where we take the peak amplitude of an instantaneous sound wave and divide that by a baseline amplitude taken when there's silence in the room. So once the controller's been calibrated, then it can compare any instantaneous sound wave to this baseline, take the natural log of that times 10, and that's what we used as our loudness. So the controller can sense a wave, interpret it as a loudness, and then use that to come up with an output.
So a block flow diagram talking about how this is working. Our set point and what we're trying to control is our desired loudness, and then are sending that through a volume is controlling to the speaker. And the main difference between the laptop and the TV is that the TV requires an IR signal sent through a remote to change one set point volume at a time, whereas the laptop can go straight from your controller to the speaker and adjust in large increments.
And so the basic components of our laptop is as shown on the screen is an example of our code showing the sensitivity analysis. So we have our speakers produce the audio, the built-in microphone can sense the ambient loudness, and then the Python code interfaces with computer hardware and actuates the speaker volume.
Unlike with a computer, with a TV, the control is a little more difficult because all of the hardware isn't integrated in one place. So here's the device we built to communicate with the TV and control its loudness. We've got here a microphone that senses the instantaneous sound wave coming from the TV, and an IR light which communicates the signals to the TV much like a remote would. The Arduino microcontroller has our code on it that can interpret the sound wave as a loudness and tell the IR light what to do. And the purpose of this IR sensor is when you're setting it up, you can teach it what signal from your remote or what signal to copy that your remote would have sent to the TV so it can act like your remote on your TV.
So a little bit about tuning the controller. So here you can see in the less stable control, we have large oscillations. We're not able to really control to set loudness and also large oscillations in our operating point. And as we were able to tune it, those oscillations are much smaller and we were able to set it to a much more consistent loudness.
And so when we run this simulation, as shown on we can see that as the volume increases, the TV sensor is adjusting for the volume and going up and down depending on the loudness that it is received.
All right, so going on to the laptop simulation, we'll be able to see the crescendo. We're going to go right to the end of this where it's really, where Hugh Jackman's really decreasing in volume, and we'll see the laptop increasing the volume to compensate for that.
This is where you want to be. It's everything you ever want.
So as you can see here where our volume is this blue line up here, you can see how it drastically increased the volume and it was able to maintain a very constant loudness despite the diminuendo going on right there. And then also you can see at the beginning how it decreased in volume as the song amped up.
So here's some results compared at the end of the song during that diminuendo of the computer control versus the TV control versus no control. So you can see in both cases the controller is able to maintain the set loudness longer than it would be with no control, so you can hear Hugh Jackman longer. That's because the TV was a little worse than the laptop because of the delay associated with the IR sensor, and we could only send up one step at a time. The computer controller, since it was integrated with the hardware, was able to actuate a lot quicker and match that volume better.
And so we conclude that laptop controlled loudness, it works extremely well with the Arduino we have built. It provides instant control of the volume. With the TV, it was more difficult because the IR remote has limited results. And the speaker sensitivity greatly affected is by the distance and calibration. If we were to improve this, we would have a more sensitive speaker and a program with a higher frequency in our IR light, and that is our report on the Cuddle Bud.